So the concept we know is HCF into LCM is product of numbers. This is true for two numbers. Please remember, this formula does not apply for three numbers. You can't apply it to HCF into LCM of XYZ is X into Y into Z, but it does apply to HCF into LCM of X and Y is X into Y. So the standard question based on this is that if I tell you that the HCF of two numbers, for two numbers, the HCF is 75 and the HCF is 75 and the LCM is 1800, and if one of the numbers is 600, what is the other number? So in this situation, what we do is, if we take the first number as X, we are looking for the other number Y, and the logic is the product of HCF into LCM, 75 into 1800 is 600 into Y, and you can solve this by cancelling that, and hence the value of Y is 75 into 3, which is 225. That's the value of Y, and this is the answer. But be careful of a trap in this question. What is the trap? Let me show you. Same question. The HCF of two numbers is 75 and the LCM of the numbers is 900. The LCM of the numbers is 900. If one number is 600, what is the other number? Now in this case, if you try this, 75 into 900 is equal to 600 into Y, and as you can see, you can divide both of this by 300. This will become 3 and that will become 2, and the value of Y comes out to be 112.5. Now first of all, that's okay, that's not a problem, because you could have had a decimal. One of those numbers could be decimals. When you say that the HCF of two numbers is 75, it does not mean that the numbers are integers. That's fine, but notice another issue. Is 75 a divisor of 112.5? The answer is no. Is 900 a multiple of 600? The answer is no. So this is a trap question on the same structure, and a lot of people solve this with this, and if I give you a question like this, I'll definitely put 112.5 as an option there. So this is the first trap. The second trap in the same question is, I tell you the HCF of two numbers is 75, the LCM is 400. HCF is 75, the LCM is 400. If one number is 20 or if one number is 100, what is the other number? Again, HCF into LCM is product of the numbers. 75 into 400 is equal to 100 into Y. That works, but this makes it 4. Y comes out as 300, but the problem, 100 and 300 do not have an HCF of 75 and they do not have an LCM of 400. What is the trap here? And what you should have noticed, remember the logic, the LCM has to be a multiple of the HCF. In this case, the LCM is not a multiple of the HCF. So just be careful of this when you do this question. Otherwise, this is a very simple, straight away, giving you marks kind of question. That's the first part. Now, the next question I want to talk about is the bell tolling question. It's a very common question in aptitude exams, which talks about three bells toll at intervals of 7 seconds, 9 seconds and 12 seconds respectively. 3 bells toll at intervals of 7 seconds, 9 seconds and 12 seconds respectively. If they are made to toll together at 9 am for the first time, all the bells ring together at 9 am for the first time, at what time will they ring again for the first time? So 9 am in the morning, they all ring together. at what time will the ring again for the first time. So in this case, what is happening is there are 3 bells. One bell which is ringing every 7 seconds has a time interval of 7 seconds for its ringing. The second bell which is ringing at 9 seconds has a time interval of 9 seconds for its ringing. And the third bell which is ringing at 12 seconds has a time interval of 12 seconds for its ringing. So what will happen is the 7-second bell is ringing in multiples of 7, the 9-second bell is ringing in multiples of 9, and the 12-second bell is ringing in multiples of 12. So for all these bells to ring together for the first time, you need the LCM of 7, 9 and 12, and that, as we know the shortcut, you should be able to write as 12 into 7, 2 co-prime numbers, and I would prefer 12 into 7 to 9 into 7 because 12 is a larger number. I want to get rid of the larger number in the co-primes, and the 9 requires an extra 3 for it to be reverse constructed from this number, and hence the value of this is 12 into 7 into 3, which is 84 into 3, which is 252 seconds. So they are going to ring after 252 seconds. So if they rung at 9 am for the first time, the next time they are ringing together again is 4 minutes 12 seconds after 9 am. So 9, 4, 12 is when they are going to ring again together for the first time. And then a follow-up question on this is, how many times will they ring together in the next 1 hour or the next 2 hours? So let's say we solve this question, the same question. How many times will they ring together in the next 1 hour? How many times will they ring together in the next 1 hour? 3 bells ringing together, ringing at 9 am for the first time. Their frequency of ringing is 7 seconds, 9 seconds and 12 seconds. They ring at 9 am for the first time. The question being asked is, next 1 hour, how many times will they ring together? So for this, once you find that 252 seconds that they are going to be ringing together in 252 seconds, once you find that information, the next 1 hour is a time period of 60 minutes into 60 seconds, which means it is 3600 seconds. And since the time interval is 252 seconds, you can just understand this is just going to be a simple division. Think of it this way, that suppose I make this noise. Let's say I start making this noise, and I'm making it at intervals of 3 seconds. And then I ask you this question, how many times will you hear this noise in the next 10 seconds? So if you hear it now and the next 10 seconds from this point, so 3, 6 and 9, so you will get it 3 times. So the logic is going to be 10 by 3, the total time interval divided by the interval for ringing or interval for the sound. So in this case, the answer is going to be 3600 by 252, which is, if you do that calculation, you can see that this is going to be 900 by 63, and 63 tens are being 6, or you can further divide this as 300 by 21, and you can see that the quotient of this division is 14, and you just need the quotient of that, not the remainder, because the remainder is going to be irrelevant. Same logic, if I'm making sounds at 7 seconds, in the next 20 seconds I'll make it twice. The extra 6 times 6 seconds I will have the remainder of 20 by 7 is going to be inconsequential because the third noise is not happening here, right? And so this is again another standard question on LCMs. And the next standard question on LCMs is, again you'll find in a lot of exams, a lot of your aptitude tests across the board, and a lot of these companies that you go for ask this. It's a standard question in the exams. What is the smallest number that leaves a remainder of 1 when divided by 2, 3, 4, 5, 6, 7, 8, 9 or 10. Now first understand the logic of this question by taking a smaller case. So suppose I ask you this question, what is the smallest number? Of course this question should be saying smallest number greater than 1. So what is the smallest number greater than 1 that leaves the same remainder when divided by remainder of 1, the same remainder of 1 when divided by 3 or 4. So the logic of this question is basically built on the LCM, because what you need to spot to find this answer is the LCM of 3 and 4 being 12 plus 1 gives you the answer. So the smallest number that will leave a remainder of 1 when divided by 3 and 4 is 13. Of course, if you don't want the smallest number and you just want a number leaving a remainder of 1 when divided by 3 or 4, then the logic shifts from the LCM plus 1, which was the logic for the smallest number, to any common multiple plus 1. So if I give you the cue that you want a number that on dividing by 3 or 4 leaves remainder 1 in every case, those numbers are 12 plus 1, 24 plus 1, 36 plus 1, all the common multiples of 3 and 4 plus 1. But when the Q is about the smallest, when that is reintroduced into the question, then it becomes, the logic moves to LCM plus 1. Right? So since this question was asking the smallest number, the question is about finding the LCM of these numbers. And when you go to find the LCM of these numbers, you can start from the higher end because you want to get rid of the larger numbers. 10 into 9 are co-prime and 7 is co-prime with them. So you can straight away write 10 into 9 into 7. Then for the 8, you will put a 4 because there's already a 2 here. Please remember the reverse construction logic. You'll put a 4 there. The 6 is already included because there's a 3 and 2 here. The 5 is already there in 10. The 4 is directly there. The 3 is there in 9 and the 2 is there in 1. So your LCM is 10 into 9 into 7 into 4, which is 2520. And hence the smallest number greater than 1 that leaves a remainder of 1 when divided by all these numbers is 2520 plus 1, which is 2521. So these are standard questions of LCM. You should just know them directly and also use the shortcuts for LCM and as well as the HCF shortcuts for those HCF questions that we have done. And I'll be back with more in my next lesson, which will be continuation of this chapter. And number systems, systems and questions related to that is one of the major areas, one of the 3 major areas in which you prepare maths. We've already talked about that. And getting your numbers in place goes a long way towards making sure that your quants part of the aptitude test is taken care of. So I'll wind up with this. I'll see you soon on the other side in the next lesson. Bye-bye.